Hello students, welcome back. In the last session, we have discussed about exceptions in Python. We have studied what is exception, how exceptions are handled in Python, and two important keywords which are used to handle exceptions in Python, that are try and except. In the last session, we have also seen one program which demonstrates how exceptions are handled in Python. In the last example program, we have seen that the block of code may generate an exception, and that exception can be handled by an except block. Now in that except block, we were handling the exception, that is zero division error exception. But a block of code may generate more than one type of exception. In the last example, we have handled only one exception, but the same block of code may generate more than one exception. In such cases, we need to handle multiple exceptions in the program. In today's session, we will discuss how multiple exceptions can be handled in a Python program. So let's start. Block of program code may raise more than one kind of exception. As I have said, a same block of code may generate more than one type of exception. The reserve word except can be followed by a tuple of exception. In such cases, we can use the except with multiple different exceptions. For example, you can see here except, in bracket we have value error, we have type error. That means this particular except block can handle both value error and type error. Two different types of exception it can handle. So the except block will be entered if any of the listed exception is raised within the try block. So this is how you can handle multiple exception in Python. Now it is not that we can handle only two types of exceptions. We can handle any number of exception in the except block. So this except block will be entered when any of those exception listed here in the except block are raised by the block of code in the try block. We can write a separate except block for each kind of exception, which allows program to choose an action based upon which exception was raised. Now the problem with this particular except is that whenever we have a value error, it will execute the same code which is defined in the except block, and whenever there is a type error also, it will execute the same code which has been defined in the except block. For all the exceptions which are listed in the except block, it will execute the same set of code. But suppose for different types of exception, if we want to execute a different set of code, or the handling of every exception we want it to be different, in such cases what we can do is we can include multiple except statements in the program. So like in Java, we can include multiple catch blocks. In the same way, in a similar way, in Python we can include multiple except blocks. Every except will handle a particular type of exception. So for example, I may say except value error and some block of code. Then I may say again except type error, again some block of code. So like this we can have separate except blocks for each kind of exceptions. Okay, there is one more way to write except. If the programmer writes an except like this, except and colon, In this case, the except block will be entered if any kind of exception is raised within the try block. If we want our except block to handle all types of exception, all types which are raised in the block of code, then we can simply handle it by using except colon. So no specific exception is declared here after the except keyword. You can see here. In this case, it will handle all the types of exception. Like in Java, we use the exception E, which exception class simply handles all types of exceptions in Java. Similar way, simply except, declaring except with a colon will handle all the types of exceptions in Python. Okay, let us look at one example program which handles multiple exceptions. And in this program, we have used separate except block to handle each type of exception. Okay, so you can see we have try. Inside the try, we have a statement a is equals to 5, comma, b is equals to 0. Then print a divided by b. So there are two statements. You can see we have initialized a and b with some value, and we have a print statement which is printing division of a by b. And these statements have been included in try and except block. Except type error, then we have a print statement, we are handling an error, unsupported operation, and then we have one more except statement. Now you can see we have two except statements for a single try block. We have first except statement which handles only type error, and the second except statement which handles zero division error. And then again we have a separate block of code for both the except statements. If zero division error occurs, this block of code is executed, and so it will execute print division by 0 not allowed if the exception is zero division error. Now if you look at the values here, a is equals to 5, b is equals to 0. So when I say a divided by b, the value of b is 0. That means we are dividing a by 0 or 5 by 0. When we divide any number by 0, it will raise an exception, that is division by 0 or zero division error. And when it raises an exception, that is zero division error, that exception is thrown at this particular statement, and that is caught by the except block here, and it checks against the exception which is declared. So zero division error, is it equals to type error? No. As it is not equals to type error, it goes to the next except block. So next except block, again it catches it and it checks against the exception which is declared. If you look at here, it is zero division error. Again it matches. As it matches, it will execute the block of statements which are declared in this except statement and except block, and the control is transferred to the next statement outside the except block, and it will execute out of try except block. Suppose if I pass a value instead of say 0 here, if I pass a value say 2 for b, so this equation will be 5 divided by 2. In case of 5 divided by 2, it will evaluate without any exception or without any error, and the result will be printed. And as the result will be printed, no except block will be executed. Directly it will go to the statement outside the except block, and it will print out of try except block. Now consider if I say value of a instead of 5, if I say value of a as some alphabet, say x, in that case it will be x divided by 2. If it is x divided by 2, can we divide x by 2, again there is an exception. So exception which it may generate, it is type error. So when it throws a type error, again it goes to the first except block, and that exception is evaluated against the exception which is declared here, and as it matches, the block of code is executed, and again from that particular point it goes out of the except block and it executes out of try except blocks, and the program ends. Now this is how multiple exceptions can be handled in Python. If we want, we can include a single except block, and inside the single except block, by giving comma, we may have list of exceptions here, but in that case the same except block is executed for all the list of exceptions which are declared in the except block. If you want to handle it separately, declare separate except blocks. Exceptions as control flow mechanism. Don't think exceptions as purely for errors. They are convenient flow of control mechanism that can be used to simplify programs. So don't think exceptions are only for errors. These are some convenient flow of control mechanism which can be used to simplify the program. The exceptions are automatically thrown by the Python interpreter. So the predefined exceptions which are there in Python, these exceptions are automatically thrown by the interpreter. But the predefined exceptions are not in all the situations in the program. In these cases, sometimes we may want to throw exceptions of our own based on certain conditions in the program. In many programming languages, the standard approach to dealing with errors is to have functions return a value, indicating that something has gone amiss. That simply means in many programs, what we do is in functions, we use some value which indicates everything is fine in the function or there is something wrong in the function. We may use some values like a boolean value true if everything is okay in the function execution. If there is some problem, we may say the function may return a value false. So Python has a statement, the statement is raise statement. The statement forces a specified exception to occur. Means in Python, by using a raise statement, we can manually throw an exception. Generally, the exceptions are thrown automatically by the Python interpreter when it finds anything wrong in the execution of a program, but it is also possible to throw an exception manually by using a raise statement in Python. The form of raise statement, it is, you can see, raise exception name and the argument. So exception name can be any predefined exception or it can be a user defined exception, and the argument for the exception. As I've said, exception name, it is usually one of the built-in exceptions, for example value error. However, programmers can define a new exceptions by creating a subclass of built-in exception class. So we can have user defined exceptions as well. So this is how we can raise an exception of our own. Okay, let us look at one example here. This example, it is to calculate factorial of a number, but in this example we want to raise an exception whenever a user enters a value which is less than 0. We cannot calculate a factorial of a number if the value is less than 0. So in such cases, in regular scenario, the Python interpreter may not throw an exception when you have a value that is less than 0. But in our program, we want to throw an exception when the value of n, for which we want to find the factorial, is less than 0. So how we can use a raise statement for that? You can see we have a try block here. Okay, that's it for today's session. In today's session we have discussed how multiple different exceptions can be handled in Python, and we have also discussed exceptions as control flow mechanism. Okay, we will stop here today. Thank you.